Good morning, everyone. So glad you're here. Thank you for joining us again. We're going to wait just a couple of minutes for the last few people coming in, and then we will get started. All right, so we're going to go ahead and get started. I hope everyone had a wonderful week. It's a little odd that we have the 4th of July this year fell on a Tuesday, and so the holiday was in the middle of the week, and I'm so confused about days. Like, I don't know how today can be Thursday. It feels like Tuesday. But we're really excited to be here for the second part of our summer session. If you were not able to join us in June, that was on the Tuesdays, and now we're moving to Thursdays for July. All of those videos are linked in this presentation, so you'll be able to get to the link. It's on our YouTube page or our website. But we are starting in with content now. Last month, we kind of covered the aspect of 3D learning and 3D teaching, starting with like anchoring phenomenon, recurring themes and concepts, and the science and engineering practices. And now we're going to take a deeper look at the actual content. My goal for today is we're going to meet these new TEKS. We're going to look at it in a very 5E kind of way, as in exploring the new TEKS. So yeah, we're going to be looking at the new TEKS and really what's changed. And then we're going to look at how we can connect these TEKS back to the recurring themes and concepts. And if you're not familiar with those, don't stress, we'll support you through that. And then do some lesson ideas on some of the new stuff that's coming. Even if you're not implementing these TEKS yet, like some districts have chosen to start implementing the new TEKS in certain grade levels. Some districts are holding off completely until next year. Some districts are kind of doing a hybrid. It's going to be important to know where we're leading. So we're going to be looking at, what is changing so that this year, as we're working through our content, we can start getting those ideas for when the actual changes occur next year. So this is baby stepping into the new standards that are coming. And then we are going to have time for breakout rooms. And during that time, my hope is that a lot of the content is changing grade levels, and you will have time to meet with your grade level companions and maybe share some ideas and lessons. Some of the content is brand new, like aqueous solutions and things like that. But some of it is just, we're pushing things from different grade levels around. And so we can support each other and share ideas and really get that time to help each other out like teachers do. So that's kind of the roadmap for today. We are going to do this as a kind of a 5E lesson, so we always want to start with an anchoring phenomenon. So the biggest, the reporting category, one interesting thing about it is that it's actually changed the name of the reporting category in a couple of grade levels. So it's now matter and its properties up until like 2nd or 3rd grade when it goes back to matter and energy. Magnetic goo. There we go. All right. So what an amazing activity this would be to help our kids explore the properties of like magnetic properties. Even just to do it as a demo where you make a little bit of slime for each, even just showing them the video itself. I know it looks so fun just to play around with this stuff. Like that is the coolest stuff ever. But this is, oops, a great way to start exploring the new standards, exploring your exploring matter and its properties. And magnets is one of those things that really has changed. It's been pushed all the way down to kindergarten. So it's going to be important for the kids to really get hands on with the material here, because that's the only way they're going to learn about magnetism in kindergarten. But kind of just referring back to that over and over throughout the lesson, that magnetic slime, that anchoring phenomenon, it was designed to only have music in the background. It doesn't have any words or anything, so that as a class, we can be having a conversation like, what are you seeing? What do you notice? What do you think is going to happen when we mix all these things together? Because not only is this, mixtures and solutions and things like that you can bring in, it's also got that magnetic factor and just looks really, really, really cool and fun to play with. So we are going to kind of take a look at all the teaks and the way that they're changing. And to do that, we're going to actually do a sorting activity. So I'm going to put a link to this activity in the chat. And this way, I think that's probably the easiest way for you to get there. And as you're getting to the activity, this is a sorting activity with the new teaks. And what we've done is place the current 2017 Streamline teaks are in blue, and the new 2024 teaks are in green. So there's little strips, little tags for each. And your job will be to kind of figure out how they match up and what is brand new and what is no longer a part of that teak at all. So all you have to do is grab it and pull. The blue is your current teaks, and we're going to see, does this line up? Do any of these blue teaks line up with the new teaks? So the current teak says, observe, record, and discuss how material can be changed by heating or cooling. And then observe and record properties of objects, bigger, smaller, heavier. So if my new teak says, identify and record observable physical properties, but there's no mention about heating and cooling. So this teak is kind of gone from kindergarten. So I'm just going to put it over the side. Hello?
Oh,
can you hear me?
Now, yeah, I was disconnected earlier when I heard you saying, you were trying to figure out whether or not anybody else was on here. And I had to log off and come back in, but I'm not able to click on the join meeting from the computer. Is there any way I can do that? Because it said that it wasn't accessible and that it might have been moved to another screen or something. Is that true? Because what I have, the join meeting is not enabling me to access.
The only thing I can think would be if it was not if you were not registered under the same Zoom login. Like, what was the registration email versus what are you trying to log in with?
The school email. My school email.
And the registration went through on that?
Uh-huh. And you all sent me the confirmation.
Mm-hmm. Okay, 1 second, and let me address that with you. Let me get everybody started on this activity, and then we'll troubleshoot it.
Okay. All right. Thank you.
Mm-hmm. Okay, so I put the link in the chat, and you can just go to your grade level or choose a grade level and start to break down where these teaks match up. Feel free to have that discussion if you want to come off mute, and if someone else is trying to kind of do the same grade level that you are, or have that discussion in the chat of what you think matches up or what you're not finding a match for at all. So there's 1 page per grade level. and you just drag and drop, and we want to match up where we can the new teaks to the old teaks, and then see where anything is brand new by just kind of leaving it off to the side. And then let me know if you have any questions as you're working on that. I'm going to give you maybe 10 minutes to kind of sort through all these teaks. So you might start with your grade level first, and then you can explore other grade levels, maybe above and below, to get a good idea of that vertical alignment piece as well. All right, 1 second then. And I see everyone's in the activity. It looks like y'all are doing a great job sorting these standards. So we'll give it, we're getting pretty close on most of them. So I will give you just another couple of minutes as we're sorting. I'm going to go ahead and pause my screen. All right, so let me resume my share, and it looks like we've got most of these grade levels sorted through. So let's kind of take a look and see what general trends and ideas that you are seeing. And please, again, feel free to come off chat or make comments in the, come off mute or make comments in the chat, either one, to make this interactive and more personalized and helpful for you. So looking at kindergarten, we already kind of looked. This heating and cooling has completely been removed from the standard. And now we are looking at, identify and record observable physical properties. And the big change here is this generate ways to classify objects. Generate is kind of a much more higher level of rigor for a kindergartner to be able to then come up with ways of actually sorting objects. And they'll need lots of opportunities to practice that. Moving to first grade, here's where you're going to find your heating and cooling. So it's been taken out of kinder, moved up to first, probably a little more grade appropriate. And this materials piece has been taken out of first grade. If you look, it's actually been pushed down to kindergarten. So when we're looking at objects, we're classifying them by their material from which they're made of. That's starting in kindergarten now. And this is a brand new standard. 6C in first grade is a brand new standard. It didn't come from anywhere else. It is in line with the recurring themes and concepts about systems and system models. So starting in kindergarten, we need to be able to put things together and take things apart. So that one's going to be lots of fun. Looking at second grade, not as much change on this one. One big, like you can kind of see where most of them line up pretty well to what we're already doing in second grade. One big change is conducting a descriptive investigation. So, having them actually do the investigation as they go through it. It not necessarily having to have all the measurement and everything, but being able to explain like smaller, larger, that kind of stuff as they go through all of these different processes. Another key here is that even though we have to demonstrate that small units such as building blocks can be combined, building blocks is not actually on the supply list for second grade. When you're looking at, the science and engineering practices of all the materials, all the supplies that the students or the tools the students are supposed to be using, building blocks isn't on there. So just keep that in mind that you will need them, even though they're not on in the actual standard for what tools the students have to use. Moving into third grade, kind of have, if you're a third grade teacher, lucky you, there is not just a whole lot of change here. There's small changes to some of the verbs and kind of some of the actual types of observations that the students are making. But overall, the standards have not changed. They've been recoded, but they're not a huge difference as far as what is actually changing. So that one is one of the few that doesn't have huge grade level changes. Fourth grade, there are big changes. We've added quite a bit here. We want to, one of the big things that they're doing here is just kind of realigning and making sure that everything kind of flows from third through fifth. And so we've added relative density just to make sure that when you're talking about temperature, it's the only thing we're talking about relative. I'm sorry. Oh, shoot. And we're talking about relative density in that one. And then it's also making sure it's physical states. The big one that has changed that really doesn't align is this demonstrate that matter is conserved when mixtures such as soil and water and oil and water are formed. So we're now talking conservation of matter all the way down in fourth grade. And so they'll need to really understand that term of conservation of matter. And they did that to align with fifth and eighth grade. Moving up, any comments so far on these early elementary grades? Any overall patterns or themes that you're seeing as the TEKS are changing? I know we've only so far had kind of a quick overview of what is actually changing. Okay. Fifth grade and up, you're going to start seeing lots of changes here. Fifth grade has one brand new TEK, and that is illustrate how matter is made up of particles. So we're not using the vocabulary of, atoms or anything smaller, but they need to understand the concept that matter is made up of particles too small to see. So that's kind of a big change. The others, again, we're changing verbs a lot, clarifying, and again, adding the terminology that matter is conserved in solutions. So that's reinforcing that fourth grade TEK, that we really need to understand that the conservation of matter is kind of a new concept, this grade level. Moving up to sixth. Some of these TEKs were moved down from chemistry or IPC down to sixth grade. So this is a huge shakeup of a lot of our of what we've been teaching at this grade level. So the first one is comparing solid, liquid, and gas. This was moved down from chemistry and IPC. And distinguishing between pure substances, homogeneous mixtures, and heterogeneous mixtures also came down from chemistry. So these two, get with your high school people if you can, and figure out what were they doing to really help understand those concepts. It's a lot of vocabulary as well. That's going to be some tough vocabulary for a lot of our kids to be able to really get those terms and understand the terms and the differences between them. One good news here, one little helpful thing is this calculate density no longer exists. It's now just compare density. So instead of having to actually do the calculations, they just get to look at it in relation to each other. So that's a little help. It's a step down in rigor, and it's more age appropriate for the students in sixth grade. But that's really the only really good news, that one. Seventh grade, another big change. I actually taught seventh grade for many, many years, and I'm just going to say to my fellow seventh grade teachers out there, buy lots of chocolate. Like, that should be on your main supply list for this year is chocolate. Huge changes in seventh grade because we really didn't teach a lot of this category. It was seventh grade has almost always been life science. And so there's a big difference. There's only one that lines up. And there's two that have basically going away. Photosynthesis has been moved to sixth grade and eighth grade. And the flow of energy in food webs has been moved to, it's still taught, it's just moved to organisms in the environment. But all of these are new to 7th grade. Now, most of them are not brand new. So periodic table, 8th grade teachers have been teaching that forever. It's, get some good materials from them. Elements and compounds, all the chemical symbols and formulas, that's not really new. But this aqueous solution and agitation, let's see, all of this that is on aqueous solutions is brand new. So investigate and model how temperature, surface area, and agitation affect the rate of dissolution of solid solutes in aqueous solutions. Again, the vocabulary is going to be killer here. And then describe aqueous solutions in terms of solute and solvent, concentration, and dilution. So this is going to require new materials. EduSmart has you covered, of course. If you are an EduSmart customer, we'll look at some of that later as far as how we need to be teaching this. But just know that that's a huge change. Those are both brand new. In 8th grade, again, pretty big shakeup here. And overall, I think the reason is that we're trying to align better so that 6th and 8th grade were really well aligned, and then 7th grade was like an island. And we wanted the realigning of the TEKS is to make it flow better through all 3 grade levels. But it does kind of affect the way that we're going to be doing this. One brand new one that moved down from chemistry is, again, the modeling how matter is classified as elements, compounds, and mixtures. So that they've done this, but the modeling piece is really important. The periodic table to identify atoms, that is a new, this is an extension of what they've already done, but we're looking at the atoms involved in chemical reactions. So it's taking it a step further. This is a higher level of rigor than was there before. Another brand new one that, well, there's a couple. The properties of cohesion, adhesion, and surface temperature. That is new to 8th grade. So that's going to be a really fun one to get all of that vocabulary. And then also comparing and contrasting acids and bases, including pH. That's all new as well. So the good thing is that 8th grade has moved, they've removed the structure of atoms, protons, and electrons, and the arrangement of the periodic table. All of that has moved to chemistry. So we're doing more on the properties of acid and bases and things and the surface water, but you don't have to go all the way into protons and electrons. That all moved up to chemistry. And then chemical formulas is what moved down to 7th grade. So as you can see, there's a lot of changes here. What is there anything that surprises you about what you're seeing as far as the changes in this standards? I know this is still like a quick brush over just what we're looking at, but these are, and they will take some time for us to really look at and get used to. It is a lot to take in. It is a lot to take in. I like this way of looking at it as far as being able to actually move these pieces around yourself. We'll be doing this type of activity with all of the reporting categories throughout the month. It's, it's one thing to kind of see it or hear it, but it's another thing to actually try and match it up yourself. So yeah, I do like that it's more streamlined, but it is a lot of moving around. And some of the stuff that's brand new is going to be a little challenging as well. Like the new ones are going to be where we see a lot of issues, and a lot of the reason that they did these new TEKS is because of trying to make it more vertically aligned. There was pieces missing that the students hadn't learned that they needed for a later concept, so they moved it around in order to be able to do that. Yeah, I love the comments that I'm seeing in the chat. Kinder and third grade were not as much affected. Seventh grade is massively affected. Seventh grade teachers are really going to struggle with, they've moved a lot out of seventh grade. So it really is just a realignment and being able to shift around how much time you're spending on things. But this is a lot to be able to add to seventh grade. Because most of it seems to be pretty new. We will get into showing you some resources of different ways that we can actually teach this material and how they're a good approach to being able to get the students to understand a lot of the changed material. But yeah, it is a lot to take in. So let's go ahead and take a little bit deeper dive into these different alignments. That was the alignment practice. That's basically our explore piece. You went in and you got to actually explore and piece together yourself and hands-on, be able to do this. And then we're going to go on to more of an explain piece. So let's look at this actual vertical alignment. Let's talk a little bit more about each of the different components. We are linking all of the documents that you have, this alignment practice. You can do this physically as well, like actually print out colored strips of paper. And we're giving you access to that and all of the vertical alignment and side-by-sides that we have. So we're making sure all of this material is available to you in order to help you as you're getting to know the new standards. And remember, you're here right now, you're already ahead of the curve, right? Just by knowing that these changes are coming, we're ahead of the curve. Some teachers aren't even going to get to see them until the beginning of summer next year, and then it will be a lot more to have to take in. So congratulations, you're ahead of the curve. But let's go ahead and dive in and just see what's coming so we can, sure, let me we'll go back real quick and share this link again. And I'll put that in the chat. And then when you receive the follow-up from this workshop, it'll have the links for all of those materials, including our vertical alignment and side-by-sides. So looking at it at individual grade levels, the side-by-side that we did is a little more in depth than the TEA version. You'll notice some things are in red. If it's in red, that means it's new. And if there's not one that matches up, that means that either it's been taken out or it is brand new. So the blue is the old TEKS, the current TEKS we have, and the green is the new TEKS. Again, notice this used to be matter and energy. It's now called matter and its properties. So we're fundamentally changing what we're looking at as far as the reporting category itself in the lower grade levels. So I think that's an important distinction to make. Otherwise, yes, you're looking at the main TEK hasn't changed, except that the students are now expected to generate ways of classifying objects. That means they have to come up with these solutions. So in one way, that's a great thing because you're introducing them very, very early to being able to create their own investigations. But it's, it may be challenging to get them to be able to distinguish things. Now, you can show them a group of objects and just say, how could I, sort these in different ways? Lots of practice on that, and they're generating their own ideas. But it needs to be very student-led as far as that goes. And then again, the heating and cooling has now been moved to first grade only, or first and second. So no, kindergarten doesn't have a huge amount of changes, but it is much more student-led. First grade, notice again in red all the changes. Big change in the verbs, being able to explain and predict, not just identify. So they have to know what is happening, not just be able to tell it and tell what's going to, make that prediction, but they have to be able to explain the process. So again, up the rigor on that. And then this one is The brand new one, demonstrate and explain that a whole object is a system made of organized parts, such as a toy that can be taken apart and put back together. I'll show you a really great activity here in just a little bit. After the break, we'll kind of look at these new TEKS and ways that we can incorporate them. But this is really taking the recurring theme and concept of systems and adding it as part of the content TEKS. And so they're getting a good foundation in what exactly is a system. And that's going to be an important foundation for them for the entire, every grade level, because it is one of the recurring themes. Second grade, there are some changes. The heating and cooling is been removed because it's now been pushed to first grade. This is that them being able to conduct a descriptive investigation. You'll see that over and over again in the new standards. The students are the ones who need to be able to come up with, generate their own, and conduct their own investigations. So it's going to put a little more of the burden of teaching onto the students themselves, which is a great thing. They need to be doing that in a very inquiry-based manner. And then, again, we're demonstrating that small units like building blocks can be made into new objects. It's basically the same TEK. It's just a matter of, it's been reworded and made, I think it's actually been made a little more clear. But building blocks need to be added to your supply list if you don't already have some kind of building block in the classroom, because it's not part of the tools for this grade level. Other than that, not a whole lot of changes. Third grade, again, nice that it's not a huge amount of changes. This 6D has changed quite a bit. Notice if it's highlighted in yellow, that means it is brand new. So it's not just been moved around, but it's brand new. So now we are actually looking at materials can be combined based on their physical properties to create or modify objects, such as building a tower or adding clay to sand to make a stronger brick, and justify the selection of materials used based on their physical properties. So that one is that one's going to be the big change for third grade. They're starting to learn about not only the properties of matter, but why they would choose, and they need to be able to justify why they choose certain materials to change their structure, change their whatever they're building in a way that makes sense. And that'll bring in like that argumentation and the conversation, the discussion pieces from all the science and engineering practices. This would be a great place for you to be able to incorporate that, because they do need to be able to justify their selection. So they have to, one of the new standards for science and engineering practices says they engage respectfully in scientific discourse. This would be a great place to have that conversation and be able to tell, why did you add that? And why is it, why did you want to do it this way in order to make it stronger or more flexible, or why would I add this particular material to make it more of whatever they're trying to build? But it's going to be a tough one to teach. Moving on into fourth grade. Fourth grade is another one that has really big changes. That conservation of matter in a mixture is new. There'll be lots of things that you just need to measure and combine and then measure again. That's probably going to be your best friend as far as the standard, is just doing that in multiple ways to be able to see that even though you just combined them, the measurements didn't change. Slight differences in the verbs. Again, this is an investigate now and not just compare and contrast. And that's kind of making it a little more broad. We're investigating to compare a variety of mixtures, including liquids in liquids and solids in liquids. So it's more specific in what you're comparing, but they have to be able to investigate it not just identify it. They need to touch it and have that that experience with it. So that's going to make it a little more rigorous for that one too. And these are the side-by-sides that we have linked so that you can actually see everything pulled out that really needs to be paid attention to. Just like this where it says compare, and now we also have to contrast. They've added volume. Here another, we've added explain, and then these new ones is the conservation of matter and particles that are too small to be seen. We're not naming them as atoms. You can introduce that vocabulary if you choose, but we're not naming it as that yet. But that's kind of where we're leading to. They added this really for that vertical alignment piece because now we're bringing in atoms and molecules into 6th grade. So they wanted to have that foundation that there's matter out there that is too small to be seen. But it's still matter. It still, you know, takes up space. It still has mass, all of that. 6th grade, I had to kind of split this and make it small, so I know it's a little bit harder to see, but you can see that they've taken out a lot. So anything that has this, this has been removed. So no more chemical symbols. We're not looking, this has actually been moved to the Earth and Space. So they've taken out a lot in order to allow you time to do the new material. But again, these two right here are the ones that came down from chemistry and IPC. So it's going to be tough to take the material that they already have and adapt it to a 6th grade functional level. But it's actually something that the kids can really grasp at this age, where we're comparing solids and liquids and gases, but specifically in terms of their structure, shape, and the kinetic energy of atoms and molecules. And depending on when you teach this, they may not know kinetic energy yet. So that might need to be something you kind of teach as dual, because that's reporting category 2. So kind of might need to keep that in mind as you go through your scope and sequence, that we're talking about how the atoms actually move, and they may not be familiar with those terms yet. And then bringing in the periodic table, we've added rare earth elements. So there was already metals, non-metals, and metalloids, but now we're also bringing in rare earth elements and their importance to modern life. So now we need to know not just what are they, but why does it matter? And it would be really great to use a great anchoring phenomenon that shows, you know, one of the rare earth elements like lithium, or in fact, I was thinking about this weekend, if anyone has ever been to Mineral Wells, or if there's anyone from Mineral Wells, they have this stuff called crazy water. And they sell it there, but it's a great story about how in the 1800s, people started drinking the water from mineral wells, and they started getting better. Like, they didn't hurt as much, and they felt better, and they weren't as crazy. And it turns out it has lithium in it. So they legit were getting better. Like, it cured people from being crazy. So they called it crazy water, because lithium is a treatment for a lot of mental illnesses. So what a great, like, real life example of why that would be important to modern life. And now they're building a new spa in Mineral Wells, because we've gone back to the older ways where, hey, you know what, that natural healing really does work. So that's just like one example of, I've been doing this long enough now that I'm looking for anchoring phenomenon everywhere. And I saw the crazy water and heard the story of all the elements that are in this, all the different minerals. And it's basically like Gatorade, only all natural version, potassium and sodium and all of these things, and lithium. So great anchoring phenomenon there if you are in Mineral Wells. But that's that importance to modern life. Like, why would it matter? Well, that's a really great way to relate it to something that would matter. And then the comparing instead of calculating, which I think is a nice step back for us. 7th grade, just take a deep breath. Like there's really nothing else you can do. Just take a deep breath. So you can see everything that's been moved or removed. Photosynthesis, again, has gone down to 6th grade, I believe, or 5th grade. And then just diagramming the flow of energy has been moved to organisms in the environment, which is really where it should be anyways. So that's very helpful. But all of this is new, and these are brand new. So the only thing that didn't change is distinguish between physical and chemical changes in matter. And that's such a broad standard anyways. Like that one was tough in the first place because it's just super broad. But now we get that in addition to periodic table, elements in terms of atoms and molecules, which is moved up from 6th grade. And then your new aqueous solutions and rates of dissolving. So I have some great resources on those for you that we'll share in just a moment. But there's just, it's going to be a big transition for us there. Just the vocabulary is going to be so challenging, I think. 8th grade, when you put it side by side, holy cow, look at all those changes. Like really in middle school, there's just massive changes. These are gone because this is what has moved up to chemistry. So now they don't learn the structure of an atom until they get up to high school chemistry. They don't talk about the arrangement of the periodic table, but that, at least as far as groups and periods, but they do have to know metals, metalloids, rare earth, and non-metals. So they're already having to learn some of that arrangement of the periodic table, but at least they're not going into like, groups and periods, so you can take a step down on that. And we're not talking about chemical formulas in 8th grade anymore either. However, now we're using instead of talking about chemical formulas, they're going all the way up to chemical reactions and understanding what atoms are involved in the chemical reaction. So they are going to have to be able to read a chemical reaction like photosynthesis. And it's actually a really good one to use. It's talked about in the 6E. By understanding and being able to read a chemical symbol, including the reaction, that would cover several of these standards, is being able to understand that photosynthesis. But they have to be able to do it on lots of different ways as well. And then again, modeling how matter is classified as elements, compounds, and mixtures. And understanding that vocabulary is going to be tough. The brand new ones, like brand new, of cohesion, adhesion, and surface tension, and a pH and acids and bases. So all that's going to be really tough. Yeah, agreed. So it is, even though we've kind of taken out the, in the chat, it says, how can you read a chemical reaction without knowing the chemical formula? And it's knowing, being able to, you are going to have to teach that part, because it's the only way that you can actually teach a chemical reaction is by knowing the formula. So it's going to involve a lot of scaffolding and a lot of stepping. And that one it does seem to be kind of, I hope that there's enough vertical alignment to get to the point where we can read a chemical reaction. The idea was that in 6th and 7th grade, they're learning a little bit more of that. So hopefully that helps a little. Yeah, you're still going to have to teach formulas. That's what it boils down to. So I wish there was help for that, because when you look at 8th grades in the side-by-side, you can just tell there's just so much that has changed. And it does help to read the, like the format for it. Here we were talking about matter is composed of atoms and have chemical and physical properties. The guide now says a student understands that matter can be classified according to its property. Matter is conserved in chemical changes that occur within closed systems. Who really has changed a lot as to what we are expecting them to know by the end of 8th grade. So yeah. Good luck on those. We do have some really great supports for you though, so we'll get into that as we go through. Again, we have the link for the side-by-sides for you so you can have those documents. There's also a really great set of side-by-sides on Lead Forward. If you haven't seen those, it took me, just to be honest, it took me looking at 3 or 4 different sources of these side-by-sides to really start to understand all the changes. So ours are great. EduSmart made fantastic documents that really highlight the changes. The TEA ones are a little challenging to me. I have a hard time reading them. But Lead Forward also has some really great side-by-sides, and they give a lot of the justification for why the changes were made. So go to instructional resources and you'll find Lead Forward's side-by-sides. I use those, I used ours and a couple other sets, and it took that to really make sense for all the different changes and how the flow should be. And we'll kind of look at some of that here in a little bit. So before we go to break, what questions do y'all have so far on just the standards themselves that are changing? It's still a lot to take in, I know. I've been working on this for, I've been working on this for a while now. Started probably back in April to really do a deep dive and try and make sure that I knew exactly all the changes. And it's a lot. This is, if it makes you feel any better, this reporting category is one of the biggest changes of all of them. So while reporting category 1 is going to be a huge change, not all of them are changing to this degree. So hopefully that helps a little bit. Yeah, so looking at the chat, obviously this is a first blush and it will take us some time to really dive in and understand. We do have some great scope and sequence kind of materials that will be coming with the new TEKS next year that kind of help with that. As far as pacing guides, the idea for this standard was definitely to Texas standards have always been super broad, but not necessarily super deep. And so I think some of this was done in the attempt to allow us to go deeper into the standards, hopefully pull back just a little bit on what you're teaching in each grade level, but be able to do a more in-depth look at the specifics of some of the standards. So I think the scope and sequence will make a little more sense, especially as you get up into the upper grade levels where it's more aligned, vertically aligned. Hopefully that will help a little bit. But yeah, there's some things that you're still going to have to go to the same level that you were teaching it before in order for it to make sense to the students. As looking at it with my teacher eyes, I see just the vocabulary being a little overwhelming for the kids. Some of the stuff that they're looking at as far as like solids, liquids, and gas, I think the students can understand that. I think that we can do a really great job of showing them what it means that the atoms are spread out or they're close together or they're, moving and all of those things, but we haven't even taught them atoms yet. So that's where your challenge comes in. So that there are some pieces of the vertical alignment that we're going to have to kind of fill in. And we'll see how that works as we implement them for the first year, unfortunately. Overall, I think the changes are probably positive. And when you bring in the reporting, recurring themes and concepts and the SCPs, it'll also help as well. And we're going to look at that after the break. We'll look at all those recurring themes, and then we'll take a look at some of the specific lessons and activities that are involved in each of these new standards to help you maybe start generating some ideas for how you want to teach it in your classroom. That's kind of the idea behind what we're going to introduce you to. All right, well, if no one has any other questions, then we're going to take a short break, about 15 minutes. Well, let's see, it's 9:57. So let's go ahead and come back like at 10:10. and we'll dive back into the RTCs and then give you some more specific concrete examples to hopefully help you feel a little more supported. Because I don't want to leave you feeling like you're not supported throughout this process. So we'll go ahead and pause, and we'll see you in about 13 minutes. All right. It is 10:11. So we're going to go ahead and pick back up. And hopefully for the rest of the session, we're going to try and make you feel a little more supported and bring down the temperature a little bit, because I know it's kind of an overwhelming feeling. As teachers, most of us have probably been through changes in the TEKS before. We remember when things have been changed around and realigned, but this really is a different type of operation altogether. Like this is not just a normal, oh, we're getting new standards. There's some major changes, and it's kind of a fundamental shift in the way we're expecting our kids to learn, which means we have to change the way that we are teaching. So if we approach it with that kind of thought and feeling in mind, it helps to know that this is it. First of all, it's okay to feel overwhelmed. We'll get through it like we always do, but we're really in a lot of ways trying to put the onus of learning onto the students and away from so much on the teachers. We have been in Texas so content driven. It's like, you kind of sometimes feel like I'm going to teach this and then this and then this and then this, and and it's just this endless line of specific content we have to teach. Whereas now we're trying to make the focus more, the students are learning how to learn themselves, how to learn science, and we're giving them more opportunities, and they are filling in the blanks. They're actually the ones who are going in and doing a lot of the work. And then you come back with your explain piece and maybe give them the actual vocabulary, but they've already explored what the content is. And so it's a big change, and it's going to require that we kind of rethink a lot of the way our lessons run. But it's going to overall, I think, be a great shift for learning for our students. When coming back from break here, I have put a link to an attendance check in the chat. If you would please just go in and fill out that form. That is how we get you your CTE credit. So with that, if you fill out that attendance check, we will be sending out a certificate for 3 hours of continuing education within the next couple of days. It may take till the end of the week or so to get that out to you, but you will get that along with a copy of the recording, a copy of the slide deck with all of the links to everything that we have that we've shared, and all the stuff that we're providing, and then some additional resources that can kind of help you as you're going through this process of learning the new standards and the new 5E lessons, and how to make your lessons more 3D and all that stuff to help you out. All right. So when we are talking about the recurring themes and concepts and how we can make these connections, how can we support our students as learning these things? How can we make our lives a little easier in the process? Because let's face it, we need all the help we can get with that. By putting it into the right box for our students, it helps a lot for them to understand the content. We did a whole workshop over the summer on the recurring themes and concepts. And if you weren't able to make that, I highly encourage you to check it out on YouTube or on our website. Because the recurring themes, it really is just a framework that we can use to help our students when they're learning new material. It's like, yes, this is new, but you know how this works because you understand this particular concept, like stability and change. So all we're doing is looking at it as a reflection of stability and change. We have included this one pager for you. It's like an anchor chart that has all the recurring themes and concepts and each of their what they mean. So you can get that little freebie. But if I'm looking at reporting category 1, matter and its properties, yes, you could 100% make an argument that every single one of those recurring themes would apply to every reporting category. But the ones that have the most direct connection, the ones that would make the most sense, are probably these four. Stability and change, such as melting, evaporating, how adding certain materials changes a mixture or a substance. All of those themes that go with stability and change, if you look at it in that lens, that box of adding something to this is going to change it. How is it going to change it? How is it going to impact it? It helps with that, being able to scaffold what they already know and add that new content to it. Cause and effect, simple cause and effect relationship. Why does that happen? Because so you added energy, so it changed forms. Like that's, solid, liquid, and solid, liquid, and gas is a great way of looking at cause and effect. Why is it a solid? We'll look at the kinetic energy locked up inside of the atoms or inside of the particles, and you can see what's causing that. So it's another great lens to use. Matter and energy is one of the recurring themes. So we're investigating the flow of energy and the flow of matter, how matter cycles through a system. And once again, here's that matter is conserved. So we're really hitting on, this is 3rd, 4th, and 5th grade especially, that conservation of matter. They need to have that as a big foundation to their learning. And then systems and systems models. This is introduced as a separate TEK in 1st grade, but we introduced the recurring themes in kindergarten. So really it starts in kindergarten and works all the way through. But we're looking at the parts of a system and how they work together to create the function of the system. So I have a great example of this in just a minute about a house. How do the pieces of a house work together to make a house work? So that is also structure and function. And so you can look at it as structure and function. And again, all the recurring themes would fit this in different ways, but these are the ones that I would really hound on to make sure my students were putting them through this lens, looking at all of these changes or all of the properties of matter through this lens of matter and energy, or stability and change. It makes the most sense for a lot of the standards. A lot of them are actually asking the students to explain and predict changes. And that's straight stability and change. How is this going to change if this happens? So you're getting ahead of that. Anytime they're making predictions, we're looking at either stability and change or cause and effect. And using those terms will help the students build that mental scaffolding that they need to really apply this in new ways, apply what they're learning in new ways based on what they've already done. So looking at that and thinking about these recurring themes and standards, and then looking at the actual new content, I'm going to show you some ways that EduSmart has gone about this. And if you're not an EduSmart customer, just know, this is a way of learning for them. So this is hopefully going to spark your ideas of how I can go about teaching this. If you are an EduSmart customer, then we got you covered, and it's all out there already for you. But this really can apply to any of these, regardless of what kind of curriculum you're using. We're wanting to give you ideas for how to implement this in your classroom. Starting with this systems and parts, like this was a big one. And it's starts early. This is an anchoring phenomenon. And it's so simple. And no, there's no music. There's no sound supposed to be associated with this. It's just showing our building blocks being broken down and the cutest little robot ever who's doing it. The kids are, the idea behind the anchoring phenomenon is that we're generating questions from the students. So the students can be like, why did he do that? And why did it break it down? And I can look at, oh my gosh, that's such a great structure. I could pause it here and say, what do you think he's going to do to that structure? And what's going to happen if he hits it? Do you think the whole thing's going to fall? Like, what do you notice? What do you see? What do you wonder? And then I can use this to drive the discussion of how all these different pieces worked together to you know, as an entire system. And there is, with that, we have a great hands-on activity called the sum of our parts, and this is that house activity. So what the students would do is, using some kind of building material, you could have them build a house. They were going to be engineers. And with their small group, they're going to build a house. You might want to talk about things that make a house, think about a house at home, or, you know, think about where you live, what parts are there in the home, walls, windows, doors, roof, etc. And then they build their house and they identify the parts of the house and then take them apart. That's going to be fun and very loud, which is great because we want science to be loud. And then you go through the activity of, could you build it the exact same way as you did before? And let them retry. We're putting back together. So it's that idea that systems are made of parts and parts make up the whole, but the whole is made of parts. And so it's not just engineering something, it's also doing the reverse and taking it apart. So you're really building that mental elasticity of it goes both ways. And then you could try another type of object, maybe a car, maybe some other kind of building, or a model of a cell phone, or whatever, you know, makes your students tick. Whatever interests them, we can find some kind of way to include that. So just like before, maybe they're just going to make a toy, and they can make whatever kind of toy they want. And then they pull it apart, and then they put it back together. They're identifying the pieces and parts of a system. So those are just a couple of ideas for systems and parts. Honestly, doing this, I mean, you could do something like this at any grade level, especially as you're learning the recurring themes and concepts. It's just a really simple, easy way to break down that recurring theme of systems and parts, and the way that that the pieces rely on each other. Looking at the conservation of matter. This is another huge change. And I really like, we're going to look at this, another anchoring phenomenon. And I've also, I should have mentioned this before, the anchoring phenomenon that I started with the magnetic slime, it came from a site by Paul Anderson. So if you're familiar with Mr. Anderson, he has some really, really great materials. I've included a link to his site because I did use material from there. But it's a great place to go look for anchoring phenomenon. It is NGSS based, so you kind of have to look for the right material. But there's a lot of anchoring phenomenon that are easily used for our Texas standards. A lot of the other material is NGSS aligned, not Texas aligned, but the anchoring phenomenon you can use for just about anything. This is a very simple conservation of matter in solutions. We are looking at, you know, oil being added. This is, they're not mixing. There's lots of things that the students would be doing while they're showing this, you know, generating questions. What do you see? What exactly are you seeing? What do you think it is? Make a prediction. It can be that simple. And then if you're doing this activity, you could measure it, combine them, measure again, and it's a real easy way. And then do something else, maybe like Kool-Aid or some kind of material that completely dissolves. And so they can't see that the mixture is, you know, that they did not, that they're both there. but they know that they are, something like sugar, where you can't really see the particles once they've dissolved, it's too small, and then have them measure it again. So there's lots of ways that you can do this activity to show that the matter is conserved. And I'm going to actually show the instruction module for this one. Our instruction module is the direct teach portion of a lesson. And let me make sure I'm still sharing my sound. This is designed to be very collaborative and interactive with your students. So I'm sure there's other videos out there you can find if you're, not an EduSmart customer. But again, this is just kind of a way of introducing the topic for our kids. Come on. Let's load that again. There we go.
Sean is all set to bake a cake for Mother's Day. He has measured the mass of all the ingredients and has them ready. We usually measure the mass of an object with a triple beam balance in a lab. Like everything around us, all the ingredients of the cake are made of matter too. We know that matter is anything that has volume and mass. Mass is the amount of matter in a substance. And it's time to make this matter into cake batter. Sean first adds the sugar into the flour to form a mixture. Why is it called a mixture?
So we have a built-in pause and we could have a discussion with our class here. We're reactivating their knowledge. We're using the cake as the demonstration phenomenon for this particular topic. So it's something that most kids are going to be able to relate to. If they've not made one at home, at least they, understand that it's made usually from ingredients. So it's something basic for them to be able to relate to. And then we have the built-in pause to discuss mixtures, talk about what that is, maybe start like a KWL chart, or I think, I know, I wonder, that kind of thing.
A mixture is formed when the ingredients or substances, like sugar and flour, retain their properties even though they are mixed together. They can easily be separated. Sean now adds milk into the sugary flour mixture to make the batter. What happened to the sugar in the mixture when Sean began to mix it?
And again, the built-in pause for discussion with your students.
The liquid milk caused the sugar to dissolve. The size of the sugar particles, a physical property, changed and the particles cannot be seen. How do we know that the sugar is still in the batter?
Another great prompting question for the students to be able to have those discussion pieces.
Although we cannot see the sugar, we know it is still there because the mixture will taste sweet. What will be the mass of the mixture?
And now we're actually asking them to calculate, but we're doing good solid numbers where they can, hopefully do a quick mental calculation to be able to make a prediction about what the mass is going to be.
The mass, or the amount of matter in the mixture, is the same as the mass of all the ingredients combined, even though some of the ingredients have changed their physical properties. Matter can go through changes, but it cannot be destroyed. This is called the conservation of matter. Sean now mixes the rest of the ingredients, and the cake batter is ready for the oven. What do you think the mass of the cake batter will be?
Now this one may take a little bit longer pause, and we could actually have our kids go and calculate what the mass is going to be. Again, just still adding fairly simple numbers.
It is the same as the combined mass of all the ingredients. Although some of the ingredients of the cake mixture, like the sugar, dissolved into other ingredients, like milk, not all substances dissolve when mixed together with other substances. For example, beach sand does not dissolve into sea water. Sand remains a solid in liquid water. They both retain all their physical properties and can be seen as two separate substances.
So I think a big part of this is making that distinction for our kids, that just because you can't see it doesn't mean it's not still there. And so that's why we took both examples, one where, yes, you can still see the the particles, and one where no, you can't see it, but it still is there. Sugar's a great one to do that with because you can test for it using sweetness, and know that it's still there even though you can't see it. And then we'll move on.
If 30 grams of sand is mixed with 100 grams of water, what will be the mass of the mixture?
And here again, we're making that prediction of what the mass is going to be.
The mass of the mixture is 130 grams, the combined mass of sand and water. Similarly, oil does not dissolve in water either. Although oil and water are both liquids, they both retain their physical properties, and mass of their mixture will be the combined mass of both water and oil. The cake is now ready. That smells delicious, Sean.
And then it just goes through a quick summary of the exact, recovers the concepts that that they learned. So it's a really great example of how we can look at all the different forms of conservation of matter as far as solids, liquids, in liquids, solids that dissolve and not, oh, I'll have to take a look at that. Thank you. We'll look at what the balance on the triple beam balance was. But yeah, it's just a really great way of making sure that they're getting multiple examples of this concept throughout the, through different substances, because they do need to see it in lots and lots of different formats. And this conservation of matter in a mixture carries through through 5th grade. It becomes really important to have that good foundation and understand that conservation of matter. In 5th grade, the big key concept here is that matter is made of particles too small to see. So again, you don't have to say the words atoms or any of the parts of an atom, but we are building that foundation for them to understand that there's smaller things that are out there. One of our really great activities for this is the particles in a balloon experiment. It helps them to be able to visualize what's going on with the atoms, to be able to understand that, that kinetic energy component. So all they're doing is taking a balloon and filling it up with air, and then they use a string to measure the circumference, and then they put the balloon in the refrigerator or a cold box for like 15 minutes so that, the cold air is going to condense the particles, and then they're going to measure it again and see what the difference is. And then we're going to do the same kind of activity with the Alka-Seltzer tabs. Fill a little plastic container. The film containers work great, but any kind of small plastic container would work. Put your Alka-Seltzer, put your water in there, and then the Alka-Seltzer tab. And so they're seeing that, there's really good background for this. They're going to actually look at the observation of before and after and compare how the particles moved, how the particles changed during each of those components. And it has some good reflection questions for you. It has full teacher directions as well, but the balloon experiment is super simple to be able to help them visualize the changes and sharing what they're being able to do. Because the whole point is that the particles are too small for them to see. So they have to be able to measure it in some other different kind of way. And that's a really great visual for them to be able to do that. And it's a quick activity as well, because, 10 minutes, 15 minutes in a refrigerator or a cooler. If you don't have access to a refrigerator, just bring a cooler, and they'll be able to see and measure and understand the difference. So that's a great way of making making the invisible visible to them by using balloons, and it is actually listed in the standard. For states of matter, this is that compare solid, liquids, and gases. And this is the one that came down from chemistry and IPC. So I'm going to show you the anchoring phenomenon on this one because it's I have a junior in high school, and I showed her this, and I'm like, you're going to love this. It's so great. Just wait. And she's like, why are you showing me this? But when you look at this video at first, oh my gosh, it's a piece of ice that's melting, but it's actually showing all three states of matter all at once. And so you can really see a lot going on in this. Yes, you have it melting, but we also have the gas forming, and all of it's just from adding the energy of heat. It's so simple, and yet for your students to be able to explain what is going on here, this is a great, great introduction activity. So it's foundational to them to understand all three states of matter in that one picture, because they're going to start by watching this and just saying, okay, it's ice melting. Like, big whoop, I see that all the time. But when you really start analyzing, what else are you seeing? Why do you think that's happening? What is going on that's causing the ice to do that? Like, there's all those questions that can be generated based on just this simple demonstration. So it's an easy way of doing that. And then in this one, I wanted to show, this is 6th grade. I want to show our instruction module companion, which is the note-taking guide that goes with the instruction module. But the reason I'm showing this is because you can see the type of vocabulary that we're talking about, that kinetic energy piece. You can tie in volume, because that would be your cross-curricular connections. Math, bringing in the volume is going to help a lot with that. The different types of movement, like vibrate, again, kinetic, the different shapes, all the properties, that type of vocabulary, and then a simple graphic organizer that helps them compare solid, liquid, and gas in shape, volume, space between the particles, the movement of particles, and the kinetic energy. Like, that's doable. And they could do this and explore this concept on their own. We could really have them do a lot with investigating, creating an investigation that would test for all of these things. Like, how could you come up with a way to test for all of that? So this is an easy way of doing it, but it's very visible, very visual for the students. So again, it's a lot for them to take in when we start talking about the space and the movement and the kinetic energy. But if we bring it down into those simple kinds of terms and just really draw pictures, use examples, and have them create their own ideas for how to test it, it would make a lot more sense for them. And then on ours, we tie in the journal prompt that asks them to go through all of the different shapes and explain it and justify their responses. So use what you know about the force of attraction, kinetic energy, and explain the observations. So being able to then put their thinking into writing. And this could be a partners activity where they actually are helping each other, getting that kid talk time. Hearing the explanation from other students is so very important, that collaborative piece. I know the first half of my career, I always made the mistake. I said, anytime we were writing anything, I'm like, writing time is quiet time. Everyone needs to be quiet so we can write now. And I learned not to do that, because they need to hear each other. If you can say it, then you can write it, but you have to be able to say it first. For a lot of kids, they need to be able to say it first. So we have that discussion, let them do a partner discussion or a small group discussion and talk it out. And then they can put that idea into writing. So, just being able to explain that concept is really important. All right, moving on to, I don't know why this one bothers me so bad. I did teach 7th grade for many years, but aqueous solutions, this would be really tough for me. And it may be because my own understanding is not as solid as I would like it to be. But It's a really good one to demonstrate the concepts here. So I'm going to show another instruction module because I feel like, and I may be wrong, but I feel like this is one that most teachers don't have a really great grasp of because the terminology is so tough. So this one is going to help all of us learn a little more about aqueous solutions. Oops. Come on. Okay, good. It's not just me. Oh.
Maya is babysitting, and they are playing with bubbles in the garden. There are many ways to form bubbles.
So
You could mix water with either dish soap, detergent, or shampoo to form bubbles. What do these solutions have in common?
So there's that pause with the built-in question prompt. We could discuss about what is the one thing they all have in common, or and they're going to come up with stuff like they all clean things, and at this point any kind of input that they're giving is valid, and we want to really reinforce that. Yes, tell me everything. What else do you see? We buy them at the store, whatever it happens to be. And then we will go ahead and move on.
Water is the common solvent mixed with different substances called solutes. Solutions that have water as the solvent are called aqueous solutions. What are other aqueous solutions you can think of?
Now, this might be a place where we really have to unpack. Okay, so all we're talking about is some kind of solution that has water in it. That's the basic foundation here of what we're trying to learn about. So what are some of those others you can think of? They may not be able to come up with any, but they can at least try and start generating ideas.
Our daily drinks like coffee, sodas, and juices are some aqueous solutions. It's time for a snack. Maya has prepared freshly squeezed orange juice. What do you think needs to be done to make the juice sweet?
So here your students can make predictions. As far as teaching, as far as the question in the chat says, are we going to be teaching the difference between liquids and aqueous solutions? Yep, because liquids don't have to be made of water. Aqueous solutions always have water as a base. I know it's a lot.
Sugar needs to be added to make the juice sweet. The amount of solute in an aqueous solution determines its concentration. When you add more solute to the solvent, the concentration of the solution increases. Now there's too much sugar. What can Maya do to make the juice less sweet? She would need to add more water to make it less sweet. The amount of water or solvent in an aqueous solution determines its dilution. When you add more solvent to the solute, the dilution of the solution increases.
So now, in general, I'm not necessarily a huge fan of free teaching vocabulary. Because I think vocabulary oftentimes needs to be taught in context. But in this case, I might go ahead and let them have the definition of solvent and solute in front of them, just because the words are very similar, and it's, which is the solid and which is the liquid. And it's basically what that boils down to is the solvent is the liquid, the water, and the solute is what's being dissolved or what's being mixed.
How would you describe the relationship between concentration and dilution? When the concentration of the solution increases by adding more solute, dilution decreases. When dilution increases because of the addition or more solvent, the concentration decreases. Today we learned that solutions that have water as the solvent are called aqueous solutions. The amount of solute in an aqueous solution determines its concentration. The amount of water or solvent in an aqueous solution determines its dilution. When the concentration of the solution increases by adding more solute, dilution decreases. When dilution increases because of the addition or more solvent, the concentration decreases.
So it is a lot to take in, and there is, yes, I think some hands-on labs. There's also a really great lab that we used to do talking about dilution, like a dilution lab, where the kids take a solution that has food coloring or Kool-Aid or something in it so that it's a bright color, red, purple, whatever, and then like mix it again with 10 drops of take 10 drops of that and mix it with 10 drops of water, and then take 10 drops of that and mix it with 10 more drops of water. And so they can literally see the dilution of the substance as it goes through being adding more and more and more water. And it's a parts per million lab. It's a real simple activity. And we have other hands-on activities that help with this concept as well. But yeah, dilution versus concentration is going to be a little bit tough for them. I think to the question, would you ask students to come up with their own experiments here? I think I would in the extension phase of the lesson. As far as, I think they kind of need a background, and they're not going to have, while they may have some practical home experience with this, like in making Kool-Aid, or hot chocolate or whatever the case may be, they don't have the words to use and put to it yet. And they may not have like connected those normal types of activities to what you're doing in science class. So absolutely, they should be making their own experiments. I would maybe do a couple of hands-on activities with them first and kind of help them with those, and then let them go crazy and come up with their own. And they're going to come up with mostly something similar, but that's okay. They're applying it to a new material, and that is, again, going to be very helpful as they are processing this knowledge. So those are some great ideas. Kool-Aid, making Kool-Aid, having them come up with their own. Aqua means water, yeah, and just like reinforcing that Latin root over and over and over again. And Ms. Appa, I'd have to look and see about the solute, because I think that changed in the new TEKS as far as what they're learning in fifth grade is the foundation. But I'll look at that in just a second on that side by side. The last, another challenge one, factors affecting dissolving. And in this case, we are looking at ways to measure. So the standard, I'm going to go to the teacher version on this. 1 second. Because it has the standard there. Engineering design challenge, and I'm going to look at the teacher version. So in this case, the students are looking at the temperature of the system, agitation, and surface area to determine what makes a aqueous solution, makes a solid dissolve in an aqueous solution. And to do this on this particular challenge, they're working at Starbucks, because that's definitely something they can relate to. Especially we're talking 8th graders here, right? So, or 7th graders. So they're gonna, you know, they feel so cool if they get to show up with that sugared water drink that they love. But they're looking at dissolving sugar in coffee or in water, and what makes the difference for it dissolving faster. Is it surface area? Is it shaking or stirring, that agitation piece, or is it the temperature of the liquid? And so they go through a whole design challenge where they come up with a way to dissolve the sugar most efficiently. And it's pretty easy for a teacher. All you need is sugar cubes. So they're not hard to get. We can look at different types of sugar, like powdered sugar, granulated sugar, and sugar in the raw. Providing those couple of materials, everything's available at Walmart, but it lets them practically hands-on explore what it means to dissolve a solute in a solution, in an aqueous solution. And I love the ideas that are coming here. Yeah. Yes. Miss Hillis, that paper chromatography lab where they the ink gets progressively lighter as they go through the different like dilutions. What a great idea that would be. So this is just, this is one way that we can really see how they're working on dissolving solids using sugar. And it's a fairly simple activity to connect that concept. And they have to, this would be like a wrap, an end to a unit where they've already learned solutions and solutes, and they've learned about what it means to dissolve something. And then they actually are doing the test and creating a mechanism for dissolving that themselves. The last one, well, I say the last one, whew, going back to 8th grade where pretty much everything is new. There's a few pieces that were around before, but again, we're looking at cohesion, adhesion, and surface tension in water. We're looking at chemical formulas and compounds, mixtures, and elements, pure substances. There's a lot to take in here. So hang on one second. Let me go back to 8th grade and under matter and energy. So yeah, pretty much everything here is new. So just know you're going to need to get with your high school teachers because a lot of this was taught in high school. It just needs to be brought down to a level where the students can understand it. pH paper for testing acids and bases. The periodic table specifically is looking at atoms involved in chemical reactions. So a lot of these are going to relate to each other pretty well. The 8.6 is chemical reactions, including photosynthesis. So that's a big one to be able to do. I know in my class, when we were learning photosynthesis, we would actually take little strips of card that had all the element names on them and form the equation on one side with like 6 little C's and 12 little H's, and 6 little O's, and then actually transform them into the product of a chemical equation, like physically move the atoms from side to side on the equation. And it's a way of kinetically, very physically learning how a chemical reaction works. So that's just a suggestion for that. If you are 8th grade teacher, this might be a good time to start diving into a lot of these topics because they are so new and it's going to be tough to get across. Like I taught the surface tension and adhesion and cohesion to a group of students, and I am part of a program called STEM Girls, and these girls were from 3rd through 8th grade and they didn't have any problem with the concepts, but the vocabulary again really got them. So being able to teach that in context of how water sticks together and how sticky water is pretty simple to be able to design those experiments or have them design their experiments, but the vocabulary is killer on all of these. So maybe hopefully our brilliant minds that we have in class today can start coming up and helping us come up with some ideas for those types of content. So we are going to go ahead. We're actually a few minutes late on this, but we're going to go ahead and go to breakout rooms. And I'm going to open up the rooms in just a moment. You can choose which room you want to go to, either elementary or secondary. And the idea here is just that even though our TEKS are changing, we as teachers have amazing resources, just like y'all have been sharing in the chat, that can really help each other as we do these hands-on and learning these new content. So it can only benefit each other to kind of start sharing ideas on things that maybe are changing grade levels. If you caught something that was like brand new to your grade level or something like that, that it would be very helpful to have some ideas on. That this is your time to share and to support and help each other out. We'll have about 40 minutes in breakout room to really be able to share, and I'll come in and check on everyone as we go. And I will also share the vertical alignment documents so that you can, know exactly what is in your progression. So you can figure out, where maybe do we need support? Maybe do we want to share some ideas and lessons? Does that make sense? Does anyone have any questions on what we're doing in breakout rooms? This is really just helping each other out. All right, so thank you all very much for some really great discussion I heard going on in both elementary and secondary sessions. So I want to pose a couple of reflection questions for you, and then I'm going to ask you to kind of share maybe what was discussed in your class or any great takeaways that you had from your breakout session. So thinking kind of overall through the standards and what we've seen today, and obviously, again, this is a first blush. I know it's going to take a lot more really, going through them before we're 100% on them, but kind of what grade levels do you see being the most affected and most struggling? Who do you think is going to struggle with the change in content? Is it more a teacher issue? Is it a student issue? Like, how are we handling that changing content itself? And then what content will be most difficult for the teachers and students? So yeah, so just either feel free to come off of mute and answer, or you can type your answers in the chat, just to kind of think through as an overall scope, thinking of your grade level or your grade levels. If there's more, what do you feel will be the most challenging? You can't just say all of it like my students would have. All of it.
I think that as teachers, we're as bad as the kids when it comes to change. We don't like it when things change. So we're gonna get it. We're gonna get it. It is just gonna take a minute or two or three.
Yeah.
But I mean, I think that I think that in the long run, I think the changes, we're going to find out the changes are going to be good across the board. It's just going to take us a little while to get used to it, especially 7th grade, since I'm a 7th grader. But like I said, I'm just like my kids. I don't like when things change, but I think it'll be okay. My anxiety is high right now, but it'll be good.
I think it will. And I think, again, you're smart to be doing this now and kind of baby stepping into it. I do think 7th grade teachers are going to have a big struggle because we have kind of been isolated as far as life science for a long time. And now it's opening up earth and space as well as energy and matter. So 7th grade is definitely, deserves a little extra support, maybe, a few more breaths of oxygen there, but it will be okay. And I do think the alignment is going to help out quite a bit. I also see a lot of comments here about changing from being the leader in the class to being the facilitator in the class. And that could be a struggle, and it could be a real struggle with some of our kids right now, because we know the discipline issues and that kind of stuff that we're seeing. And there is a difference between that style of classroom management where you're in, the front of the room and you're teaching and you have a certain level of control of the class, and then giving that facility, handing over to them where they're the ones who are now going to be coming up with their own investigations and doing a lot more hands-on and research and all that kind of stuff. And so that can be a little intimidating for teachers as well. It's just the style of them doing the descriptive investigation and coming up with their own stuff. So yeah, I can see where all of that would be a struggle too. Investigations are going to be a big part of it, and letting the students lead the investigations is going to be a big part of it. So awesome. Yeah, I think I love that y'all were sharing emails, because I think we're all going to need that support. You know, it's a great way to look for and to get support from other teachers. I think more so than ever, we're going to really need to be looking for our other grade levels and our other teams to really help support as we're learning new standards. So that'll be a big test, key. What other takeaways? Anybody got any big takeaways that they're kind of getting from this? Something that someone said in your session that was like, that we all need to hear? Anything to help everybody out?
I've noticed a lot of people are really stressed. And one of the things I'd like to remind you is that a lot of it's staying the same. There are some changes, but there's also a lot that's staying the same. And it's sort of fun to try new things. So if it's, the problem's going to be if you have a lot of changes in the same unit.
Yeah.
But if you only have a couple changes in the unit, it can sort of make it more exciting because you have a little bit different. It's not like you're in the same rut.
Excellent point. Being able to kind of change things up a little bit, it helps us as teachers stay fresh too. I think also we need to know that it's okay to explore with our students. Some of these topics we're kind of maybe not fresh on. School was a long time ago for me as far as my own education. I haven't been out of the classroom long, but my own education was a long time ago. And so there's things I don't really remember, and it's okay to explore with your students and to let them know that you're learning alongside them. And, oh, wow, that is the coolest thing. I'm so glad you taught me that. And, we have to be comfortable having that bit of vulnerability with our students. This descriptive investigation or using these discovery-based learning allows for that in a much more natural kind of way too. So when we're changing content and learning, we're able to do that with our students and do the discovery with our students.
We talked about this in the secondary breakout about admin. If they don't have a science background and they're in our rooms observing us with these new TEKs and the SEPs and the RTCs and all that stuff, RTCs, that because they don't know what we are currently going through, I'm afraid we're going to get dinged.
Yeah.
In our observations. And I really think it's important that we tell our admin, hey, look, this is what's going to happen. This is what you're going to see. And, give us a break.
I absolutely agree. I think our admin, first of all, don't have a clue what we're going through because of, because every grade level or every content changes over time. So they're like, yeah, science is changing. I'm sure my teachers can handle it, but I'm not sure they realize what. Yeah, it's important to set those expectations early. Day one of school, you go in and tell your students things are going to be different this year. And, that's just, you're setting your expectations and this is how it's going to look. And there you go. And do the same thing with your admin. It's going to be different this year. And this is what you need to look for as opposed to, this is how it's going to be. Yeah, there you go. Creating some look fors and know what it should be like. And that it very well may be that your class is the loudest class in the hall, and that is okay because it's all inquiry. Your kids should be loud when they're learning and exploring. And if they're working on, those kind of discovery-based learning, it's going to be loud. Awesome. Well, I just have a couple of little wrap up things for you before we go. We do want to invite you to all of the remaining sessions for the summer. We'll be covering one reporting category. Oh, that's reporting category 4 organisms in the environment. But we'll be covering one each week, every Thursday, same time, 9 to 12. I have included, this is a link to the registration. So when you get your follow-up for this session, you'll have the link to register for the other sessions if you would like. If you are new to EduSmart and you're curious about what we are, there is a free trial, a free preview you can use. So the link will be there. It's on edusmart.com. And we're including all the resources that we showed you today. So all the side-by-sides, the vertical alignments, there's an anchor chart for recurring themes and concepts, the lesson plan template that helps to set up 3D learning, and then links to all of the other workshops that we've done this summer over the other content pieces. So I saw in the comments on the attendance check, like we want to learn more about anchoring phenomenon or incorporating recurring themes. These are ways that you can begin to do that. Also want to definitely give credit. This is that website by Paul Anderson. He has amazing anchoring phenomenon that are they're just a really good anchoring phenomenon, and there's a lot of them, so there's really good ones to choose from. And that's really all we have for you. So does anyone have any questions, comments, or anything they want to share before we take out?
Can you put that back, that last page, please? Thank you, Colo.
Yeah, it's a great website. And this is a link to the website where it has the anchoring phenomenon. And again, the rest of his stuff is really well aligned with NGSS. So you do, kind of watch that alignment with Texas, but there's also some other great resources there. And my name is Leah, or my email is leah@edusmart.com. I'm the director of professional development, so everything I do is training. That's my whole job. And anytime, anything you need, just reach out. Feel free to ask questions, whatever you may need. That's what we're here for. We want to support our teachers as we go through this change. So otherwise, thank you all so much for giving up 3 hours of your summer to be here. You will get your 3 hours of credit, and I hope to see you next week.